Hello all, it's John, the founder of John Academy, in a brand new video, and today we're going to cover the hardest SAT math questions in the problem solving and data analysis section. Let's start with the first question here. A survey was taken of the monthly rent of one-bedroom apartments in a neighborhood, and it was found that the mean monthly rent was 1,680 and the median monthly rent was 1,200. Which of the following situations could explain the difference between the mean and median rent prices in the neighborhood? So in this case, we can imagine we have a list of numbers, no, the rent prices. So we could have 1,000, 1,100, no, 1,200, and then some higher values also, no. So it could be 3,000 and 5,000. This could be a good example of what we described, no, just with the exercise. Why? Because here the median is the one in between all values, no? As there are 5 values, 1, 2, 3, 4, and 5, the one in between is the third one, exactly. So the median is gonna be the 1,200. But what happens? The rent, or yeah, the mean rent, no, the mean monthly rent is gonna be higher than the median. Why is that? Because there are very high values. The lower values are closer to the median and than the higher values. Therefore, these are gonna drive the mean up. So it's gonna be B. There are few apartments that are much more expensive to rent than the rest, no, the 3,000 and 5,000. So it's gonna be B, the correct option. That's the one we're gonna take. We could also see why the others are wrong. There are few apartments that are much cheaper, will be the opposite case. The mean will be lower than the median. In this case, it's bigger, no? And the rent prices for one bedroom apartment are very close to each other. Well, it's not the case, no? In that case, the mean and the median will be very close. That's why. In this case, mean, we could write similar to median. And in this other case, the mean would be smaller than the median. And the last one, let's check also. The monthly rent for one bedroom apartments are between these two values. Doesn't have anything to do, no? So we discard it also. It's gonna be B. Let's jump into the next exercise. This one is related with an exponential function. The population of city Z was 50,000 in 1983, no? And then the population doubles every 5 years. Which of the following best describes P, the population of Z between these 2 years, no? So what's gonna happen? This is gonna be a growth exponential function, no? Therefore, it's gonna be between A and B already. Those C and D are linear functions, so we discard them. And then, which of the two exponential growth functions is the correct one? So if it doubles every 5 years, it's gonna have t divided by 5 in the exponent. Because every 5 years, you are gonna have 2 to the power of 1, which is double. 2 to the power of 2, which is double once again. 2 to the power of 3, double once again. So that's why it's gonna be A, the first one. Let's check this next question, very easy also. A geneticist is studying the inheritance of white eyes in male and female fruit flies, no? Based on the information in the table, what is the approximate percent relative frequency of white-eyed male fruit flies, no? White-eyed male in all male fruit flies studied, no? So the total number of males, yeah, so they are asking white-eyed male, so which is 62, over the total number of males, and the total number of males is 62 plus also the normal ones, no, 21. And this we can do it on the calculator directly. 62 over 62 plus 21, and this gets us, well, 0.746, which we can round, no, and convert into percentage as 75%. So it's gonna be D, the correct answer, last one. Let's read this next question. Based on a random sample of river heights, estimate that 4,800 cubic kilometers of fresh water is discharged into the Arctic. Has a margin of error of 240 at a 90% confidence level. Which is the most reasonable claim, no? So we have a confidence interval, no, which is gonna be 4,800 minus the margin, or 4,800 plus the margin, no? And now if we calculate this, what can we check? 4,800 minus 240 is 4,560. And the other one is gonna be 5,040. So it's gonna be it's gonna be the second option. It's gonna be between these two, no? Most probably. Let's check this next one, average pickup mileage, and yeah, we have this graph, no? This is SMM plane, approximates the average mileage M in miles per gallon that Dennis pickup truck gets when she drives at a speed of S miles per hour. What is the best interpretation of the maximum point? The maximum point is the one here, no? 18 at around 55 miles per hour, no? Dennis trucks gets a maximum mileage of 18 miles per gallon, gets a maximum mileage of 55 miles per gallon. This one is wrong because it's the speed, 55. Dennis trucks can drive at a maximum speed of 18 miles per hour, wrong. It can drive much faster, as we see here on the x-axis. And Dennis trucks can drive at a maximum of 55 miles, also wrong. Is the first option. Why? Because it's gonna be consuming so many miles per gallon, 18 miles per gallon, at the speed of 55. That's what it's telling us, no? Let's jump into the next question. A study was conducted on the effect of classical music on puzzle solving. 500 randomly selected college students were asked to solve a jigsaw puzzle. Half of them were assigned, half with are listening to classical music while solving, other half were not. The ones who were listening to classical music, it took them 25 seconds longer to solve. Which is the most appropriate, no? So listening to classical music is likely to lengthen puzzle solving or shorten, no? Well, obviously it's not gonna shorten, no? It was taking 25 seconds longer, so we can discard B. Listening classical music is likely to lengthen the time needed for any activity. Any activity is a claim that we can't make, no? It's just for this experiment we were seeing, no? For puzzle solving, so we have to discard C. Classical music is the best genre of music to listen to for shortening puzzle solving. Well, obviously not, because it is increasing the time, no? So it's gonna be A, the correct answer, no? But we also discarded all others to make sure it was a good choice. Next question is fairly easy, no? We are given 343 meters per second, and we have to translate it into kilometers per hour, no? So let's remember how to do that. 1,000 meters are equivalent to 1 kilometer, no? So we divide by 1,000 meters and multiply 1 kilometer. And now, in order to bring from seconds to hours, 3,600 seconds are equivalent to 1 hour, no? And what happens? Meters get cancelled with meters here. Seconds get cancelled with seconds here. The result is now gonna be in kilometers per hour, no? The two units we have here and here. And we have to multiply this number times 3,600 and divide by 1,000. So let's do that on the calculator, no? So 343 times 3,600 divided by 1,000. And that's equivalent to 1,234.8. And it's asking us to round to the nearest whole number, so that's gonna be 1,235. Very easy, no? well, kilometers per hour, no? Here we don't have to enter the unit, but that will be very good. Let's check this next exercise. At the beginning of the week, Josh had 32 computer games. And he was having so many more than Peter. Okay, by the end of the week, okay. So we are gonna have two cases, no? Start and end of the week. So let's check for each of them, no? At the start, we have Josh. Yeah, we could write J for Josh and P for Peter. Okay, in each of them. Josh is 32 and he has 133% more, no? So that means that Peter times 1.33 should be equal to 32. Therefore, P equals 32 divided by this 1.33. And let's see what's that equal to on the calculator. That's almost 24, no? Yeah, 24 if you round it, no? Basically. So here we have 24 and 32 at the beginning, that way. And then what happens? At the end of the week, Josh gave 25% of his computer's games to Peter. So 25% is going that way. 25%, yeah, 25% of 32. And how do we calculate that? It's gonna be doing 32 times 0.25, which equals 8. So 8 are going from Josh to Peter. Therefore, 32 minus 8 is gonna be 24. And here we are adding those 8, no? So 32. And then at the end of the week, what's gonna happen? Josh had 24 and Peter had 32. That's the correct answer, C. Very good, we got it there. This one is fairly easy. Two friends rented a table at a ping pong parlor, no? The table costs $10 for every 30 minutes and they spent $40. So first of all, it's gonna be $40 divided by 10. They played four games, no? Each of the games is 30 minutes. So it's going to be 4 times 30, which tells us they played 120 minutes. Ah, no, sorry. They did four. Yeah, they paid 4 times basically, no? And then each of the times they paid was 30 minutes long, so 120 minutes. And then this 120 minutes we have to divide by how long it lasts each of the games, so 20 minutes. And this gives us they played 6 games, no? That's why. So final answer is 6 here. So now we have this last exercise here. The scatter plot depicts the average monthly temperatures F in degrees, okay. Which of the following functions best describes the relationship shown? So this looks like a quadratic function, no? As we can see. So we could use Desmos to graph each of these 4 and look which one looks more similar, but we can do it even faster. Why? Because a quadratic function of this shape, like a sad face, no, we could say, a sad face, this means that A, no, the first letter A is less than 0. If it's like a happy face, A is bigger than 0. So we can already discard C and D. And then to choose between A and B, what can we know? At the time of crossing the x-axis around here, no, we see this has a positive slope at 0. Therefore, this, the B is gonna be bigger than 0. Otherwise, it would be something like this. And then it's crossing the y-axis, basically, no? X equal to 0 is crossing negatively. But in this case, it's crossing with a positive slope. Therefore, it's gonna be B, the correct answer here. And we can also check it with Desmos if you want, but it's gonna be that one, no? So very good. We got all of these exercises done. I hope you learned a lot of concepts, very useful for the SAT math, and we will see us in another video. Bye then.